Myself, Dr.Monika Khetarpal. I am Associate Professor of Physics in Government Dongar College, Bikaner. In my virtual lab, I am going to discuss an experiment on inverting operational amplifier. This is the basic circuit diagram of inverting operational amplifier. This is the symbol of op-amp. Op-amp has two ports. One, which is shown by negative terminal, is termed as inverting port, and the another terminal shown by positive is a non-inverting port. It has one output. This is the output terminal. Since we are using inverting operational amplifier, I am giving my input on this inverting port. I have used two resistance. First is the input resistance and another resistance RF is the feedback resistance. Here we are using negative feedback. Now, what is the gain of this inverting operational amplifier? Gain is defined as output voltage divided by input voltage. The gain of this operational amplifier is minus RF upon Rn. RF and Rn are the two resistances. First, RF is the feedback resistance and Rn is the input resistance. Here the negative sign shows the inversion of output with respect to input. That means as it is 180 degree out of phase. Now, in order to draw this inverting operational amplifier, we will use LTSpice. This is the circuit diagram that will make finally. Suppose we are expecting a gain of 10. For this purpose, we have to choose our two resistance. Let I am choosing my input resistance denoted by R1 to be 1 kilo and the another resistance which is feedback resistance to be 10 kilo ohm. This will give me a gain of 10. Now, the voltage sources that are used to power the operational amplifier, let them to be 15 volts, and the input voltage that I am going to give to this inverting port, let it be a sine wave. Now, let us begin to draw this circuit diagram. So, let us choose new schematic and now we are going to choose our components. The first component that I am in need is operational amplifier. So, let us start by choosing an op-amp. I am choosing an op-amp which is universal op-amp 2. This is my op-amp. The other components are also required. Now, let us choose our other components. I am choosing resistance. This is my first resistance which is an series resistance. The another resistance will be a feedback resistance denoted by R2. Now, I have to choose the voltage sources. So, I am choosing my voltage source. I have to choose 3 voltage sources. The first source which I have taken will be connected to the inverting terminal of op-amp. The other two voltage sources, they are used to power the operational amplifier, and these two voltage sources are V2 and V3. Now, we will make the connections. For this purpose, first of all, I am connecting my inverting terminal to the series resistance R1. Now, I am connecting my series resistance to feedback resistance. Next I am doing is connection between feedback resistance and the output of op-amp. I am connecting my input voltage to the series resistance. Now I have to connect the two power supplies of op-amp. These voltage sources denoted by V2 and V3, they are connected to the operational amplifier. Now this is the connection that I have to make, and the another component that is required in order to complete this circuit diagram is a ground. I will connect my non-inverting port of op-amp to the ground. So I have taken these ground. Now I am making connection of ground to the non-inverting terminal, and the input voltage is connected to the ground. The power supply of op-amp, they are also grounded. So this is the required connection. Now I am choosing my required components. First of all, I am choosing the series resistance R1. Let this series resistance R1 to be equal to 1 kilo ohm. The another resistance, that is feedback resistance, let it be 10 kilo ohm, so that gain comes out to be a factor of 10. The voltage sources which are connected to the op-amp, they are chosen to be 15 volts. Now I have to give input, so I am choosing my input wave to be a sine wave, and let its amplitude to be equal to 10 millivolts and frequency of it to be 50 Hertz. This is my input signal, that is a sine wave. Now I am going to run this circuit diagram and see how our output comes out to be. So let's first of all check our input wave. Students, you can see that my input wave is a sine wave which has an amplitude of 10 millivolts. Now we will check our output. Our output is shown by a blue line and input is shown by a green line. We can see clearly that output is a sine wave and which has an amplitude of 100 millivolts. Now, in order to show it clearly, you can clearly see that there is a 180-degree phase difference between input and output signal. This is my input signal and this is my output signal, and they are in opposite phase, and we have a gain which has a factor of 10. Since my input wave has an amplitude of 10 millivolts, and you can see that it has an amplitude of 10 millivolts on the y-axis, and output signal, it has an amplitude approximately to be 100. So my output wave has an amplitude of 100 millivolts. So we can simulate our operational amplifier using LTSpice. Thanks a lot for watching.